approaches at the input, right? At the input, I will show you what the input, at the input approaches some value. The input approaches some value. As input approaches some value. So you say that in mathematics, a limit is a value that a function approaches at the input approaches some values. That is the definition. So you say this is the value. Maybe 2, it may be a half, maybe 0.5, but it's a real number. It may be a certain later. Okay, is a value that a function approaches. So we'll be seeing some function as input, at the input approaches to some values. So we say that we have an input and output. So a limit is an output of the function. An input, it means that is what we say that as we approach. So an input is the one that converge. So when an input is converged means that we approach the input from left and right, then we get the output, which is y in terms of the function, because the function have y and the x. So x is an input in most cases, and y is what is an output. Okay? So that's the piece of information. So another question that, why do we study limits? That's the questions that we have in our mind. Okay? So this is the question, just a brief question. Why do we study limit? Why should we study limit in engineering? That's the homework that you should think. Why should we study limits in engineering? Why should not pure mathematicians study only limit? Why we engineers and scientists we need to know the concept of limit? So you say limits are essential. So limits are essential to calculus. So the concepts of limit is very essential, very important means to calculus and mathematical analysis. And mathematical analysis. Mathematical analysis, and I used to define continuity, and I used to define continuity. Why do we need? So we want the concepts of continuity in engineering, right? We also used to define the concepts of derivatives. It means about differentiation. So we need differentiation in engineering. And what integrals. So we mean about about integrations. So this is one of the reasons. So limits are essential to calculus and mathematical analysis. Have analysis at the one branch of mathematics. Why? Because we use this limit to define continuity, derivatives, and integrals. Right? So because we are using derivatives, we are using continuity, we use integrals, then we need to define this concept of limit. However, that in this topic of theory of limit, we'll be focusing on on continuity, right? So, that is all about general definitions of limit, right? Just to give you an example before even I move forward. The example of function that including limit is in case you have limit x approaches to 4, and then you have x squared minus 4x, possibly that over x cubic. So that is example of the limit, or the question that as x approaches, so this is input, this is output. So the response that you get there to be a limit. So against might be that let's say x approaches to a half, and thence you find that you have x squared plus 4x minus 3 over t over x. So those are the examples. So for instance, that you can find that the limit in terms of limits itself, so that as limit as x approaches to 3, and then here we have 3x minus 9. The answer is 0. So this is the limit, and this is the input. So this is the function which you can find its limit. This is the function you can find its limit, but as x approaches to 4, here as x approaches to what? To half. Right? So what you say limit, for example, let me give you the last example. Say that as limit as x approaches to 3 or approaches to 1, then here we have x squared minus 1, right? Or x squared minus 5. So the answer is equal to -4. Or for instance, that x squared plus what? Plus 1. So if you find the limits for this case, I will teach you how we can find is 6. Right? So this is the limit is 6 and this is the output. So 6 is input, output, this is an input. I will show you how we get those concepts. In case you have any questions, don't hesitate ask in the comment section. I'll try my level best to help you to understand, but make sure that you work hard. Okay, so those are the examples of 40 of general definitions of limit. Then now let us go to the mathematical definition of a limit of the function. Limit of 40 of a function. So mathematical definitions of a limit of a function. What we want to teach you here. First of all, we want to give you information, very important information. There are two types of 40 of mathematical, or there are two mathematical definition of what? Of limit. Right? So let me mention them. The first one, call it informal. Informal definition of limit. Explain to you what does it mean. Second one, we call it informal definition of limit. Formal definition of 40 of limit. So you have those two definitions of 40 of limit. The first one is informal definition of limit. The second one is called the formal definition of limit. These are mathematical. So instead of mathematical, we can define them and give them the formula. The previous definition of limit, it can't give us formula. Okay, so This is the technique, or one of the teaching aids or technique that the Lord has given us. Whenever we are teaching you some of the higher engineering and scientific mathematics, we also have to recall what you know in advance. So we can build our foundations of higher engineering and scientific mathematics on top of what you know, right? So you say that you want to define, first of all, that you want to define this informal definition. Informal definition. But the way that you can define this informal definition for an ordinary student is a little bit complex. It's better if we do geometrical representation and then come and define it. We say that a limited function a limit of function, as Atlas approaches to that, can be defined geometrically. Can be defined geometrically. Be defined what? Geometrically. How we can define it geometrically? So let us start with prerequisite. Prerequisite of what you know about, or some of the mathematical concepts that you have that can assist you or help you to understand the self-limit. So let us begin with something we call it inequalities. Okay, let's say geometrical. So this is just like a quick review. So let's say geometrical representation of a function, let's say. Not a function, let's say, geometrical representation of numbers, let's say. So I will start with positive number. So let us consider figure 1 below. Right? This is suppose this XY axis. Listen carefully, follow me along. I'm doing the quick review prerequisite. Possibly you've forgotten this concept. Right? In many institutions, they just used to go straight for it and give you the formula of informal definition, which is not right, because it's a little bit difficult for you to understand how did you do a shifting. Suppose that you can have, let's say, that a certain function that maybe it has been drawn here in this shape. So this is the certain function that we call f of x. Listen carefully. Then we want to know the value. So this is y-axis and this is x-axis. Okay? Suppose that this is 2. Listen carefully. So because that is number 2, listen carefully. And then we say that you agree with me that all of the numbers before 2 on the left hand side, these we call them are the numbers, suppose that this is x, which are less than 2. Right? Listen carefully. And then this side, we can call it left hand side. Again, the numbers are on the right hand side of this line, we call them, these are x greater than 2. right? And then we say that this is x. We say that this is right hand side of x is equal to 2. So listen carefully. So because that the numbers on left hand side of x is equal to 2 are less than 2, in mathematics we use this symbol. Listen carefully. We say that x, as x approaches to what the number here is 2, right? Then you use this negative bar to indicate that as x so you say as x approaches to 2, this is number 2, right? As x approaches to 2, okay? So as x approaches to 2, so that is, so in x approaches to 2, in mathematics you say that as x approaches to 2 bar. So that means that left hand side of x is equal to 2. Then we got the right hand side, x is greater than 2. How do you write in mathematics? So you can predict it. This image we write as x approaches to 2 positive bar. Many teachers, they fail to understand from what you know. So whenever you see as x approaches to 2 positive bar, it means that the right hand side of what? Of a number, right, of 2. And then so whenever you see that as x approaches to 2 bar, right, then that is left hand side of what? Of a number. Don't get confused. Right? If you didn't understand, repeat that video several times so that you understand. Because what am I doing? I'm doing the point that I want to make is I want to show you where do we get these symbols. X approaches to 2 bar, x approaches to 2 positive bar. Where do you get them in mathematics? That's what I want to show you. Okay, so this was figure 1. 121. Okay. Then we want to go for part B. Again, we need to draw another geometrical representation. Okay. Suppose that this is our XY plane. And this is our x-axis. This is the y-axis. Right? So this is x-axis and that is y-axis. Suppose today we have another number which is -2, but on left hand side this is 0. So this is our line. When we divide or we define our limit of the function, we used to say that an input should approach 2 but should not equal to 2. Just like this. Right? So you say our number today, our input is -2. So it begins with this side. This side, believe me that regardless that this is negative number, but you agree with me that on the left hand side of this straight line, so on this side we say that x is less than -2. Do you agree? Remember you are O-level algebra or diploma algebra. Do you agree? Okay, so if you agree, that is true. And then so on this side we say that x is greater than -2. You agree? Accept that x is equal to -2. Okay. You believe that on left hand side of this line it is what? Left hand side. And on this side it is what? Right hand side. Okay? So we want to discuss the limit of the certain function as x approaches -2. How do we interpret it in mathematics? Well, so this as x approaches -2, and it's left hand side, so you say that this is as x approaches to -2. Okay, approaches -2. But now because left hand side we have negative bar. Okay? Do you understand what are we talking? What are we discussing? These are still simple concepts, but we want to get you the entire picture. And then so you come on this side. So this side you say x is greater than -2. So that's right hand side. So it will be x approaches to -2 but positive bar. Right? Positive what? Positive bar. Right? That is. So for instance, again, on the same diagram, let us use another number, let's say 3. So simple to know that what do we mean about this. So for instance, here you agree with me that all the numbers on left hand side of this line are less than 3. Right? And then we agree that all the numbers on this side are greater than what? 3. Right? This is normal inequality. Our number is 3. Okay? So then, this one we call it left hand side. And this is what we call the right hand side. Right? And here we are. Okay, so because x less than 3, it's on left hand side, we use this symbol to show it. As x approaches to 3 bar. Right? Okay, because soon we're going to use letters. Then here we are. So it means that now, if that's the case, x is greater than 3. So in ordinary diploma, we write just like this one. That x approaches to what? 3. Okay? So as x approaches to 3, but this is positive. So I told you that this positive sign, 3 bar of positive, 3 bar of negative. That means what? Those are the numbers less than . Okay. So this is the general concept that you should bear in your mind. So I've used the just the, we call them integers or counting numbers or whole numbers or yes, count numbers or whole numbers. See, once again to build on top of that, you can have a geometric representation now. Okay, so this is y-axis, this is x-axis, right? This is origin. Listen carefully. Suppose that we have a certain function. F of x. Okay? Suppose that here we have a certain letter. And let's say x is equal to 4, but we don't want to mention it. So what are we going to do? Algebra gives us permissions to let that is a. Right? It's a. So it's a. You can get is 5. right? Gets the value. So suppose that is A. So this is the value of 40 of A. Okay, that's A. So it means that all the integers and even non-integers on left hand side, these are x less than A. Right? X less than A. And here we are. All the numbers that are used to be behind of the number, then it is what? Here we say that this is x greater than r. By using latest number instead of using number. First example I used numbers, second example I used what? As position, right? So it means that this x less than A, we write that x approaches to no. So you say that yes, x approaches to A. So for this one, as I said, that x approaches to A, and because it's left hand side of A, then you have negative. Right? Then you have what? X as approach to positive A. Right? So x approaches, and then now we used to 40 bar of positive. Okay, so from here, now we can define the definitions of the informal definition of limit. Because you have piece of information about the news, and then we can have even a simple description of the function. And I'll explain it to you in detail in the near future. Okay, so these are the definitions. X approaches to A bar, X approaches to positive bar, that is. So listen careful now. Okay, again another part of prerequisite, we say that this is the, we call concept of what? So let us recall the concepts of 40. First, the principle. First, the principle in calculus. Recall the concepts of 40. First, the principle in calculus. Say first, the principle. So the principle we used to learn that f of x dash x dash, this is equal to limit as x approaches to what? For distance to A. For there it was as x approaches to changing x. And then there we have what? Then we say that there we have f of x, that's small change in x, and that's f of x. Okay, divided by what? So this one divided by small change in x. when we let the small chain to be x, we say ffx dash. For example, if we let change in x is equal to h, so say ffx dash limit as x approaches to h, for instance. Then we have ffx as h minus ffx. And divided by what? By h. So this is the common principle that during your Form 5 you learn TT in calculus. Also, if you've been doing basic applied mathematics, you learned about that. Also during your ATA level 5, and you learn also about that, the first principle in differentiation. As x approaches to it, as x approaches to h. So this is the way that we use to write what? Derivative of the function itself, which is like a formula, limit. This is the way that we are writing the limit, or you write the limit, right? So it means that the way that we can write the limits of the function, we say that now limit of the function. This is the very confusing part. Is equal to it. So limit of the function, for instance, right? We say that for instance, we have limit as x approaches to 3, 3x plus 4y, okay, maybe plus 1 plus x cubic over 4. So you see the way that you write. So this is the function, this is the limit, this is the value. So you say that generally, limit is written as limit as x approaches to a, as x approaches to a, and then here we used to have ffx, and this is equal to r. I'm just writing the format of writing the limit. This is input and this is output, so this is the function. So this is the general form of writing writing, whether for negative integer or positive integers or fractions, of writing limit, right? So then I believe that up to this moment you've understood. So I can give you the informal definition of what? Of limit. Because you have to remember this first principle. So even if you do remember that, you just find, let's say, ff2 as x is equal to x cubed, x equal 4. Right? So then we say that, okay, fine. So xe minus what? X power 4. Excuse me. For instance, that you want to differentiate the function, so the function here, which is as x is equal to x squared, as in first principle. So we used to write that as limit, first with that x maybe approaches to h, then we used to say that instead of x squared, let me give you just a simple example. For instance, you will be given a function if f(x) is equal to x squared. And then use first principle to what? To find what? Find dx of x squared. So for instance, I use the first principle, right? So we say that for this case, limit as x approaches to h, and then have ffx plus h, so it is x plus h, and this one is square, right? And then we say that minus what? Fx, which is x squared, of what? Over h. Right? So you say that, just I want to remind you, because we want to repeat this stuff once again. Approaches to h, right? So this one will be x squared plus 2xh plus h squared minus x squared, for instance, over h. So this is the point where you have noticed the concept of limit, but the issue is you are not using the value of limit. We've been using it less, right? So then we say that this one, we say limit as x approaches to h, right? And then this is makes what? So x squared minus x squared to 0. So this is twice xh plus h squared over h. Right? Good. Why? Because x squared minus x squared has been ended. So you can simplify now. The 1h, the 1h. Then you see, say the limit as x approaches to h. So this is what? Twice x. Twice x plus what? Plus h. So you used to take the value of x, which is h, and substitute there. So you see that 2x plus what? 0. So the answer is 2 what? Twice x. So this is how we have been using limit in calculus. When we learned it in the subject called basic applied mathematics, or when we learned it in advanced mathematics, or when we learned it in ourselves, or when we learned it in ordinary diploma. So that's what we've been doing, right? That's why I said that the general formula is just like this one. So now I'm ready to bring to you the literal definitions of limit, right? So say that informal definition of limit. So you say that if f(x) is defined for all x near, right, near to A, except at x is equal to A. And if we can ensure, that f(x), right, f(x) is as close as we want to L as x approaches. Just write this definition, then I'll explain to you what does it mean. Approaches A, but not, okay, but not what? Not, okay, but not equal to A. Equal to A, which means that x is not equal to A, right? Then f(x) approaches to L. This is infinite definition to limit, and this limit is L. Say as x approaches, as x approaches to a. Let us just end there and explain, give you brief descriptions, and you'll enjoy. Keep on enjoying. So now we are speaking mathematically now, because we began to speak in terms of the functions or formulas. Okay, so let me explain these informal definitions now. The general definitions of informal is beginning. So as I said, if f of x is defined for all, so it's defined for all x, so it means that is because this f of x is the function that we say that f of x is the function of x, right? So this is y is equal to a certain functions of x, right? For all x near to a, except at x is equal to a. That's the first condition for informal definition. And if we can ensure that f of x is close as we want, so this f of x, y, is close as we want to limit as x approaches to a, but not equal to a, then f of x approaches to limit. That's all. So listen carefully. We say the general formula of writing a, you say that is this one. So listen carefully. This is equal to R. This is what we call informal definition. I repeat, let me explain this first. If f of x is defined for all x, so this f of x is a certain function. It can be a rational function, it can be a linear function, it can be quadratic function, it can be cubic functions, so any polynomial function, right? And then we say that it's defined for all x near to a. So near to a. So this is a certain number, fixed value, near to a. Okay? Except at x is equal to a. Except at x is equal to a. And if we can ensure that f of x is closer, so if we can ensure that f of x, what f of x, this function, is closer as we want it to L. L stands for the limit. As x approaches to a but not equal to a. Okay, then f of x approaches to what? To limit. What does it mean? We say that a limit of a function we can find when x approaches to a. Then we have the limit of the function. That's the simple descriptions. Before even just I explain to you in details. Or I can give you even the other definitions. Don't worry about that. What do we mean, first of all? Right? We say that, so you can choose it, that is definition of the other one. We say, listen carefully. As x approaches to a, but x is not equal to a, right? Simply, we say that f of x is equal to limit. That's all. What does it mean? Geometrically. Geometrically, can present informal definition. Listen carefully. This is y-axis, this is x-axis, right? So you have y-axis, and this is x-axis. So this is origin. Suppose that this is A. Listen carefully. This is A. So because this is A, we say that if you draw the dotted line now, remember that what I told you, on this side we have values or values of x, or numbers which are less than a. And then this side we can call it the left hand side of a, right? And I told you that this in mathematics we just write now accurately as x approaches to a bar, means that values of x from left hand side towards a. And then at this point here, only at this point, only at one point, right? Only at one point, x is equal to a. So x is equal to what? To a. Again, we have another part of that value, or value of x, value of y, is this side. So on this side, we say x is greater than a. And also, this one we go to right hand side of A. And mathematically say that x approaches to A but positive. Positive. Right? So, what do we say? We say limit will be defined as the value of y when we approach A from left hand side towards A, and when also we approach A from right hand side toward A, but not at x is equal to A. That will be called the limit of the function. Let me repeat. A limit of a function is a value of the function when x approaches to A from left hand side, right? And when x approaches to A from right hand side, but not at x is equal to A. That's the meaning. So if f of x defined for all values near to A, except at x is equal to A, and if we can ensure that f of x is close as we want to L, right? As x approaches to A. So as we approach A from left towards A, and also as we approach A from right side towards A, if we'll get the same value, that same value is what we call the limit. But not at x is equal to A. So the only unwanted point is x is equal to A. But we have two wanted points. Okay, two wanted sides. So we have left hand side and right hand side. That's what we want to determine the limit of the function. Don't worry. I'm here to make sure that I simplify this concept. Believe me that this is kind of the hard concepts we are beginning with in sort of limits to understand it. I remember because I taught more than 2,000 students physically this concept. So I know how they have been getting troubles to understand it. Right? So before that, this begin with the informal definitions or the formula. Listen careful. Listen careful. In order to have informal definition of the formula, let me repeat, right, with another numerical representation, just like this one, right? This is origin. So this is y-axis, and this is x-axis. Suppose that this is A. Listen careful. We have two sides. Left hand side, which is x less than A, this is equal to left hand side, right? And then we want to find, we have maybe a certain function, right? We have a certain function, right? So this certain function, our aim, we want to find the limit or the value of y, because limit is the value of y. So this is what we want to find, the value of y, limit, right? And then we say that, let me just use a large geometrical representation so you can see. Limit is nothing but very interesting concepts of function. Let me help you. This is y-axis, this is x-axis, this is origin. So this is y-axis, this is x-axis, right? Suppose that we have this function y is equal to f of x, and then suppose that here we have a, and then that we want to deal with it. Suppose that we have a straight line that begins with a simple function like this. So this one we just call it a, but let us call it L. L means limit. It's the value of y, right? So you have to, they have two sides of a. We have left hand side, which is x less than a. This we call the left hand side, right? And then you have right hand side, which is x greater than a. This we call the right hand side, right? And this one I told you in mathematics, we are writing that as x approaches to a bar, this is not negative, it is bar, to indicate that we are approaching a from left hand side toward the a, but we don't reach at the point when x is equal to a. Only one point. And then this one, we write that as x approaches to a positive, to indicate that we are approaching a from right hand side towards a, where the values of x are greater than a. The values of x on this are less than a, and the values of x here are greater than a. That's the meanings of this bar and this positive sign, right? That's the meanings, because we're gonna use these symbols soon. So how do we define we define this limit of the value? So L will be defined, means that we need only two conditions. The first condition, just one condition. We say that the conditions for L to exist. However, that will teach us application, right? Condition of L to exist, limit to exist is this. The limit of left hand side should be equal to the limit of right hand side. What does it mean? The limit as we are creating the value of y as we approach x towards a, near to a, towards a but not equal to a, should have the same value with the value of the function as we approach x from right hand side towards a. That's the meaning. So it means that to determine limit or to have informal definition, we just need limit of left hand side, and then the second conditions, limit of right hand side. That's all. So let me break it down. Seems like you're getting confused. Don't get confused. So we say that the necessary condition for a limit of a function to exist is this. The limit of left hand side of the input should be equal to the limit of right hand side of the input. Where are the limits of left hand side? The limits of the left hand side, we say that this of left hand side is very important. We write it as limit as x approaches to a bar. This is limit of left hand side, right? So is this one. So as x approaches this one. So of a certain function, certain unknown function, which is f of x, should be, for example, equal to L, right? And also, we say that the limit of right hand side also means that as we approach A, from right side towards A, this we write like this one, of a certain function, unknown function, but the same function like above should be equal to L. So once the limit of left hand side is equal to the limits of right hand side, hence the limit existed at the value of limit, right? So that's why that we say that now for the limit to exist, we say that the limit as x approaches to a bar of f of x, this should be equal to the limit of right hand side x approaches to a positive, it means values greater than a, here values less than a of a function f of x, and this will be equal to what? Limit. So we say that mathematical informal definition of limit is given as this. We say limit as x, the detailed definition, x approaches to a of f of x. This one should be equal to the limit of right hand side. Remember that this is left hand side and this is limit of right hand side. Refer those geometrical figures. This is figure 1.4. Okay? Approaches to A. These are the values of x greater than A of a certain function of fx. This is equal to R. So keep this formula the rest of your life in calculus or in engineering. You're gonna need it. So the general definition now, right? The general informal definition of limit. So this one and this means the limits of left hand side and the limits of right hand side together. We can represent them by using the single formula, which is this: limit as x approaches to A of a function will be equal to R. So this is the general formula. So whenever that we find, let's say for instance, we find that limit as x approaches to 2 of x squared plus 4 over, let's say, 3x plus 4 is equal to 3. This means that the limit of this rational function x squared plus 4 over 3x plus 4, as we approach 2 from left hand side, is equal to the limits of x squared plus 4 over 3x plus 4 as we approach 2 from right hand side towards 2. So here we have to find two limits: limit of left hand side and limit of right hand side. If they are equal, then we have a limit which is equal to what? To 3. That the means. So it means whenever we write this definition, this is the general, which is combining definitions. We have to translate that the limit of left hand side as x approaches to a bar is equal to the limits of right hand side which x is approaches to a positive bar, and that's why that we have L. So remember also here I present the limits of left hand side, right? So these are also important formulas, right? So these are the important formulas also. You have to keep them. Also, this is another important formula. This will give you limit of 40, right hand side of the function, or right hand side of the input, like this. So remember, limit is nothing. L is nothing. It's just the f of x or y, which has been conditioned. That we say that this is provided that, so you have to write here, provided that x is not equal to a, but we have just approached a, but x is not equal to what? To a. So even this one is provided as long that we say x is not equal to what? To a. So this is a informal definitions of limit. We're going to use this formula in next lectures effectively. So you have to bear it, you have to understand. In case you have any questions in the comments, I've tried my level best. I'm not sure if there's any teacher who will teach you the concepts of limit in this formality or in this style. I'm not sure. Possibly there is, but I spent much time on preparing this lecture and how can I present this new idea in your mind, and it has to stick in your mind so that you enjoy it, because always I love my students. They used to tell me that, yeah, now we understood the concepts of limit, and it will be difficult to understand, to forget. Okay, so that is the general sentence or general issue. To say that if f of x eventually gets closer and closer to a specific value L as approaches a chosen value a from the right, then we say that the limits of f of x as x approaches a from the right is L. Okay, that the limits of that one's general definitions. Remember that we say that this is not exact or precise definitions of a limit. The formal definition is more precise, and the exact mathematical definitions which will be discussed later. So let me end this session with that sentence. Right? So he said that, I think that this should give you a homework, okay? Okay. So he said that informal, so this is the note, informal definition is not a precise, say precise, or it's not a precise or accurate definition of limit, but formal definition is more precise than informal, right? More precise and accurate. And this one will be discussed later in this topic. We will learn it in this topic. So to summarize, what I wanted to write in your mind, the general definition, the contents first, the subtopics of the topic of the theory of limits, the general definitions of limit, and the informal definitions of limit from the geometrical concept that you know, from inequalities concept, from first principle that you know in calculus, and also we came into the desired informal definitions and deduced its formula from the geometrical interpretations of a function, right? I gave you 3 definitions of a limit, so make sure that you go through. Let me leave you homework for you, right? Homework 01, okay? And mention 5 applications of 40 of limit in engineering. Okay? So this is the end of lecture 1 of theory of limit. I'm very happy. I thank God who have been with me since preparations of this lecture. And I thank God who have given me power to teach you this lecture. And I thank God who have given you an opportunity to be with me. And I'm praying for you. Pray for me also to make sure that I do what I said and I do what God wants me to do before at the appointed time that He wanted me to do. And then I would like to invite you into the next session when I'll be teaching you about applications of informal definitions of limit. So don't miss, stay connected and stay tuned. We'll be together soon in lecture 2 or 40 of applications of informal definitions. So, and then we'll be solving some problems, and then we'll have another sessions of lecture 3, which will be doing more questions of informal definition. So thank you very much. May God bless you. I appreciate, and I actually thought I'm very happy for your time. I believe that you have got a lot of concepts. In case you have any question concerning about what I've been teaching, ask in the comment sections. In the comment sections, tell us also you're enjoying this material, from which institutions or from which college or from which university, and how helpful are this material in your undergraduate life. Also tell us from which city, which continents, or which country, because we have a plan to reach thousands or 40 of undergraduate students with the beauty of engineering and scientific mathematics. So thank you very much. Let us meet together in the next session. May God bless you.